Hello students, welcome back to next lecture. In today's session we are going to discuss about pig Latin operators. We have discussed pig architecture and pig data model in the last session, and today we are going to discuss about different pig Latin operators. So the pig Latin operators are broadly classified into three categories. Those are, the first one is data access operators. The second one is data transformation operators. The third one is diagnostic operators. These are the three different operators which we are going to discuss in today's lecture. So in data access operators we are having many operators. Among those, the major operators I am listing over here. Those are, one is load operator, the second one is dump, the second one is store operator, the third one is filter operator, the fourth one is for each operator, fifth one is group, the sixth one is join. These are the different data access operators which we are going to discuss in next 2 or 3 lectures. Similarly, among data transformation operators, we are having union operator, split operator, limit operator, cross operator, distinct operator, sort operator, sort by. These are the few data transformation operators which we will be discussing. Similarly, in diagnostic operators also, we are having dump operator, describe operator, explain operator, fourth one is illustrate operator. These are the 4 different diagnostic operators. Diagnostic operators can also be called as debugging operators. We can also call these as debugging operators. So this is the classification of different pig Latin operators. The pig Latin operators are broadly classified into 3 categories. One is data access operators, the second one is data transformation operators, the third one is diagnostic operators. Among data access operators, we will be discussing load, store, filter, for each, group and join operators. In data transformation operators, union, split, limit, cross, distinct, sort by, all this we will be discussing in data transformation operators. Similarly, in diagnostic operators, we can also call those operators as debugging operators. We will be discussing dump operator, describe, explain and illustrate operators also. So we will see one by one. We will start with data access operator. We will start parallelly all these operators. Whenever we require, we will be taking those operators and we will be explaining with syntaxes as well as examples. Okay students, and we will start with data access operator. The first one is load operator. So we will discuss one by one operator in detail with syntax and examples. Let's start with load operator. This operator is used to store, to load. This operator is used to load data from file system into a relation. It loads data from either local file system or HDFS file system into a relation. So this operator is used to load data from either local file system or from HDFS file system into a relation. We know what is a relation. Relation means nothing but a set of tuples. Relation is a set of tuples, and you can call this relation as a temporary buffer. We can call that as a buffer. Whenever the data stored in this relation, it's a volatile data. If we close the grunt shell or if we shut down the system, whatever the data present in this relation will be deleted. So it's a temporary buffer actually. The permanent storage of the data will be in either local file system or in the HDFS file system. If you are dealing with Hadoop, then it will be stored. The permanent data will be stored in the HDFS. If you are not dealing with Hadoop, then the data will be stored in the local file system. So whatever the data present in the local file system or HDFS, that data needs to be loaded into a relation first. Once the data is loaded into a relation, then we can apply many transformations on that relation. Okay students, fine. Now we'll see the syntax, how the load operator will look like. The syntax of the load operator. The left hand side should be always a relation name. We have to specify a relation name at the left hand side equals to relation name equals to load followed by the file name. File name should be in the single quotation or double quotations using function as schema. This is the syntax of usage of load operator. On the left hand side there should be a relation name equals to load. Which file you are going to load, that file name with complete path you need to specify, and using function as schema. This is optional. Whatever we have specified in the square brackets, that is an optional in optional usually. Okay, now we will discuss each parameter here. The relation name can be anything. It's a user defined name. The relation name can be user defined. You can put any name which you like. And the load is an operator. It is an operator. This operator will load the data from local file system or HDFS into this relation. Okay. Under this file name, the complete path of the file, where does this path exist, either in the HDFS or in the local file system. The complete path we need to specify here. Complete path of a file we need to specify. And the next things are the optional one. Using function. The function are of different types. We'll discuss those functions now. As schema. Schema means we have to specify what kind of fields that a particular file will be having. That will be specifying as a schema here. So now we'll be discussing about the function here. The functions can be four types. The functions can be four types. Those are, one is pig storage. The second one is text loader. The function names can be any of these. The third one is bin storage. And the fourth one is JS on storage. These are the four different functions we can use while loading the data from file system into a relation. Usually by default we'll be using the pig storage. This is a default function which the Apache pig will take. Pig storage means it loads and stores the data of structured files. In order to store the data of structured files, if the data present in a structured files, or if you want to load or store structured files, then you'll be using pig storage as the function. And if you want to load and store unstructured files, then the appropriate function to use is text loader. It is for unstructured files. If you are having the data which is present in unstructured format, then you can use this particular function to load that data into a relation. Similarly, the third one, the bin storage. If you want to load or store the data which is in machine readable format, If the data is in machine readable format, then use bin storage as the function, machine readable format. So the first one is to load and store structured data. The second one is to load and store unstructured data. And the third one is to store the data which is in machine readable format. The last one is to load and store the data which is in JSON format. JavaScript object notation format. If the given file is in this format, then the appropriate function to use is JSON storage function. So there are majorly 4 functions available in PIC. The functions I have listed here: PIC storage, text loader, bin storage, JSON storage. This is for structured data, this is for unstructured data, this is for machine readable data, and this is for JSON format data. And coming to the schema, schema can be written in such a way that we need to specify the column name, first the column name, followed by semicolon, followed by colon, and followed by the data type. This is the syntax of specifying the schema. If there are n number of column names are there in the file, then there should be n number of columns in the schema. Column name followed by colon, followed by data type. Example I'll be giving. If I take ID as a column name, colon, the ID will be usually in the form of integer type. The data type, the appropriate type is int here. So likewise we can write the schema of your given file or data. You have to specify here. And as I said, like, this is an optional one. This entire thing is an optional. Using function as a schema is an optional one that we'll discuss in the next part. So as I said that this part is the optional part. We can also write this as load just file name. This is also valid one. If I write like this, then by default the function will be, the function which it takes will be PIC storage function, and the schema in the sense the different column names and its types we are specifying. The column names will be, by default the column names it take, the Apache PIC will take is $01, $02, $03. Likewise it will take the column names. If it didn't give the schema, then by default the Apache PIC Latin will consider the column names as the first column name is $01, the second one is $02. Likewise it will represent the column names, and the type of these data will be, by default it is byte array. By default it is byte array. Once again I am repeating, if we didn't specify any function or schema, then the default parameters are, the function will be, the default parameter will be PIC storage, and the column names in the schema we have to specify the column name, colon, data type. The column names it represents are $01, $02 likewise, and the data type it assumes is everything as byte array. Okay students, we have discussed the different data types in the previous class when I was discussing data model, PIC data model. We have discussed about int, float, double, char array, byte array. All these are the atomic singular data elements. So in that I'm using byte array here. Byte array is the default data type given to the columns if a user did not specify any data types in the load function, load operator. Okay students, fine. Now we'll see an example how we'll be writing this load operator. Now we'll see an example. I have taken, if you observe in the left hand side, I have taken the sample text file called employee.txt. It's employee.txt file I have taken, and I have assumed some data in that file. The data is of type structured format only. The first one is I'm taking this as employee ID. This I'm treating it as employee ID. This I'm treating it as employee name. This one as the company where he or she is working. The last one is salary. These are the column names I have enclosed for them. I have put for them. Okay, the first one is employee ID, employee name, company, and the salary he or she getting. Assume this is a text file and this is the data I'm having. In this I can represent, I can tell that each row, each record is a tuple. I can call this each record as a tuple. This we discussed in the last class. Okay, now I want to store this file is present. Assume this file is present in the Hadoop distributed file system, not just 9 records. Assume it's a large amounts of data. We're having some millions of records of employees working in different companies that I'm going to process. What kind of processing I'm going to do, that we'll discuss later. For time being, I just want to load this data into a relation first, because this data is present, this text file is present in HDFS, Hadoop distributed file system. Assume this particular text file is present in the stored in the Hadoop distributed file system. Now, in order to apply some transformations on this particular data, I need to load this data into a relation first. I need to load this data into a relation first. So, in order to do the task, I'll be using an operator called load operator. Okay. Now, let's see how we are going to load this data into a relation. The relation name can be anything. As I said that this is a user defined name. The name I'm putting for this is employee. The relation name is employee data. I have put a name called employee-data as a relation name equals to load. I'm using a load operator to load the data. The file name I've taken is employee.txt. The file name is employee.txt. You have to give the complete file name, followed by, you can either stop here or you can even give all these parameters also. I'm giving the parameters here I have assumed that this is a structured data, so I'm using pick storage function, pick storage, and this function will take one parameter. This function will take one parameter. That parameter represents the delimiter of each field. If you observe in the text file, in this file, each field is separated with which particular character? Students, if you observe this data and tell me, each field is separated with which character? With comma character. I have specified commas here. So I have to specify that to the Pig Latin compiler, that the data is the fields in the data in the particular text file, each field is separated with comma. That I have to specify here. If it was separated with spaces, then I need to specify space here. If it was separated with some other characters, then that character I will be specifying here. Okay. So using pig storage, this is a delimiter. The fields are delimited with this character. Okay. As I have to write the schema here. The schema, as I said that the schema is written in this format: column name, colon, data type. If you observe, there are 4 columns here: employee ID, employee name, company, and salary. So I have to write 4 fields here. As the schema I am representing it. The first one is column name is employee ID, colon, employee ID is of type int, comma. The next one is employee name, colon. The type is char array. We don't have string in pig, so the appropriate data type is char array, comma. The next one is company, where she or he working. It is also of type char array. The last one is salary. Salary is of type big integer. I can take big integer. So, likewise, I can load the data. I can load the data from any file system, either it is a local file system or it is a HDFS file system, by using this syntax: relation name equals to load, give the file name, you need to give the complete path here, using which function I have used? Pig storage. Why I have used pig storage? Because this is of type structured data. So only I have used pig storage, and this is a delimiter. Each field is separated by this particular character. If you observe each field, 801 Harita is separated with comma. Similarly, Harita and TCS is separated with comma. So the delimiter I have to specify here. As schema I have to write. I have taken only 4 columns. employee ID, employee name, company, salary name, and their type also I have to specify. So by this, with this, we have successfully loaded our data into this relation. Now this relation contains all this data. The employee data is a relation name here. This employee data contains all this data. Relation is nothing but a collection of tuples. A relation in Pig Latin, a relation can be defined as set of tuples. You know what is a tuple? Tuple is a ordered set of fields. Ordered set of fields. Okay. So likewise, we can store the data. And students, I'll be giving a few more points here. If I remove this is optional, no? If I remove this, assume this part also I have removed. I have only taken this part. Relation name is equals to load employee.txt. Yes, I can load the data in this format by using this format also, this syntax also. In that case, the function by default the function it will take is pig storage. The function it take is pig storage, but the delimiter should be, by default it will take /t. The delimiter by default it will take /t, but here in your text file the delimiter is comma. So you cannot skip this function here. You have to write the function here because in your text file the delimiter you have specified is comma, but by default the pig storage function will take the delimiter as /t, that is tab space. So which is not correct in this case. So you have to specify the using pig storage also. If you change your file data in such a way that each field is separated with tab space, then you can go ahead with this format. Okay, fine. Assume we have separated with tab space, and now it will take pig storage /t. As the schema will be like this, it will take each particular field employee ID as $01 and its type as byte array. By default the type is byte array. Similarly, the second column name as $02 and the type is byte array. $3 type is byte array. $4 type is byte array. So total 4 columns. So each column name it was represented with $01, $02, $03, $04 likewise. If you didn't specify any column names, then Pig Latin will give the names to those particular columns in this way. And the type it will take by default is byte array. Okay. So now we have to verify whether the data is successfully loaded or not, isn't it? We need to check it, recheck it that. So for that we'll be using one more operator called dump. Dump is a diagnostic operator. It is a debugging operator. By using this operator, we can check whether the data is loaded into a relation or not. So the syntax of this particular operator is dump relation name. A simple syntax. This is a syntax of using the dump operator. Dump operator is used to dump the data which is present in this relation onto the monitor. It will show the data which is present in this relation onto the screen. So previously I have taken a relation name called employee data. Dump employee data. If I write like this, then whatever the data present in this relation, I have loaded this data into this relation, isn't it? So that data will be displayed onto the screen for me, and the output will be, the output for this particular operator will be like this. It displays all the data in a tuple format. The tuple is represented with this one. The tuple is represented with open bracket and closed bracket, open parenthesis and closed parenthesis. So it will be used, it will be displayed in the tuple format like 8 not, how many tuples are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 tuples are there. So 801, comma, Harita, comma, TCS, comma, 50K. This is one tuple. Second tuple, 810, Vasudha, TCS, 1 lakh. Likewise, it displays all the tuples till the last one. The last one is 534, Arun, Infosys, and 93K. This is the output we got when we execute this dump operator. Dump operator will dump the data present in the given relation onto the screen. Okay, okay students? Fine. Now this is the second operator. Now we'll discuss the third operator. The third operator is filter operator. We'll discuss the filter operator next. Filter operator will filters the required tuples based on a condition. Filter operator will filter the required tuples from a relation based on the condition which the user has specified. So now we will see the syntax of this filter operator. The syntax of filter operator is, again the relation name, on the left hand side there should be a relation name equals to filter, this is new relation, old relation, by condition. This is the syntax of using filter operator. Filter operator will filters the data from the old relation based on the condition. Okay. Now let us see an example. If I want to retrieve the data, this is the data I'm having, this is the relation data I'm having. If I want to retrieve the data in such a way that the entire data of a particular employee who is working in TCS, I need the data of all the employees who are working in TCS. How many people are working in TCS, students? Totally 3 people are working in TCS. So I need to extract those, I need to filter those 3 records and I need to give it as an output. That kind of processing, that kind of analysis I'm going to do. For that, the filter operator is a suitable operator. Okay, I want to filter only these 3 rows, only the rows which the employee details who are working in TCS. So for that, the appropriate operator is filter operator. So already this entire data is present in a relation called employee data. I have stored the entire data in a relation called employee data. Now I want to extract, I want to filter only few tuples from that relation. So I will be taking a new relation called TCS employees equals to, I am applying filter operation, filter. The old relation is employee data. Based on which condition I am going to filter? Based on the company. If the company is TCS, then filter those particular tuples by company double equals to TCS. As TCS is a string of type char array, specify that in the single quotations. So likewise, I can write the I can use a particular filter operator. I want to filter the data from this original data in such a way that all the employees who are working in TCS, I need to dump it as the output. So for that, I'll be using the filter operator, filter. The original relation is employee data. In this relation only, the entire data is residing. By the condition is company equals to TCS. If the company equals to TCS, then filter all those particular records or tuples, and that entire data will be stored in this relation. This is a new relation. TCS employees is a new relation. In this relation, now I'm having only 3 tuples. What are those 3 tuples, students? The first one, the second one, and the third one. So if I want to check whether this particular relation contains those data or not, the operator which I need to use is dump. Dump TCS employees. If I write like this, then the output it gives for me is, the output is 801, Harita, TCS, 50K. That is first tuple. The second tuple is 810, Vasudha, TCS, 1 lakh. That's 807, Maithili, TCS 75K. This is the output generated from this dump operator. So whenever you want to filter any data from the given relation, then apply the filter operator. Okay students, fine. So we have discussed three operators till now. One is load, to load the data from local file system or HDFS into a relation. Once the data is stored into a relation, then only we can apply the transformations on that particular data. Until and unless we store the data into a relation, we cannot perform any transformations. Okay, for that we use load operator. The second one is, if we want to check whether that particular relation contains the data or not, then the appropriate operator for that is dump operator. And if we want to perform any analysis on that, if we want to extract any required tuples from particular relation, then the appropriate operator for that is filter. Filter the given relation based on the condition. So the next one is order by. Order by operator. This operator is used to sort the data present in a relation based on some fields. Fine. If you want to sort data present in a relation, then the suitable operator for that is order by. The syntax is, how we can use this? The syntax is, new relation name is equals to order, which relation you want to sort, that relation name, by which field you want to sort, that field name, in which order you want to sort, either in descending order or in ascending order. That you have to specify here. This is the syntax of using an order by operator. New relation is equals to order, it's an operator, relation, which relation you want to sort, that relation name, by based on which field you want to sort that field, and in which order you want to sort, either ascending order or descending order, that you need to specify here. So an example I will be taking. The new relation I am taking it as sorted data, order, old relation is employee data. This entire data is present in a relation called employee data. By, I want to sort this data based on the employee ID. I want to sort this data based on the employee ID. So by employee ID. If I write like this, then by default it will sort the data in the ascending order. If I didn't specify the order here, then by default it will sort the data in ascending order. If I want to perform descending in descending order format, then I have to specify the order here. Okay, so new relation name is equals to order, the old relation, the relation which contains the data on which you want to perform the sorting operation, by based on which field you want to sort that one, and in which order, either in ascending order or descending order, you have to specify here. If you didn't specify this order, then by default it will sort the data in ascending order. If I write like this, then the data will be sorted, and that sorted data will be loaded into this relation, sorted data relation. This is a relation. This is a relation. If you want to check the output, then which operator you need to use, students? Dump operator. Dump sorted order, sorted data. If I write like this, then I will be getting the output on the screen. So how the output will look like? The output will look like in the sorted order. In the descending order, I have sorted. So which is the highest one? 810. 810 comma entire tuple. The next one is 807. The next one is 801. The next one is 534. All the data will be displayed. The next one is 264, 259, 203, 193, 146. Likewise, the data will be shown onto the screen. The output will be shown onto the screen. Order by is a operator which can be used to sort the data of a given relation. Okay, fine. Now we'll see one more relation. We'll see one more relation. Let me add one more field here. 203 Akhil Wipro 69K. Assume this is a relation. This is a data, and this data is loaded in a relation called employee data. Now I want to eliminate the duplicates. If you observe this data, this relational data, this data contains duplicates. Which is a duplicate tuple here? This one. This one is a duplicate tuple. 203 Akhil Wipro 69K, 203 Akhil Wipro 69K. If you want to eliminate any duplicates, then the appropriate operator for that is distinct. Distinct is an operator which can be used to eliminate the duplicates. To eliminate duplicates. If you want to eliminate any duplicates, then use distinct operator. If you want to eliminate any data, duplicate data in a relation, then the appropriate operator is distinct operator. Then how to use this distinct operator? Syntax. Syntax is new relation name is equals to distinct old relation name. Which relation you want to distinct space the relation name. Which relation you want to sort? You want to eliminate the duplicates. That relation you have to specify here. The output will be loaded into this relation. For example, let's take distinct data. Distinct data is equals to distinct is a operator, and on which relation you want to perform this operation? On employee data. So distinct employee data. Okay. So now the distinct data will contains only unique values, unique data, but not the duplicates. You assume there are 10 records here, 10 tuples here. So this distinct data relation will contains only 9 tuples because the duplicates are eliminated. This distinct data relation will contains only 9 records because we have eliminated the 10th record, which is a duplicate record. So students, we have discussed a few operators in today's class. Those are, the first one is load. We have discussed to load the data from HDFS into a relation. The second one is in order to check whether any relation contains which data, then the appropriate operator for that is dump. The third one is we have discussed filter operator. In order to extract any required fields, required tuples from the relation, apply filter operator. And the fourth one is we have seen order by to sort the data, and the fifth one is distinct operator. These are all the operators we have seen in today's class, and the rest of the operators I will be continuing in the next session. So till then, have a nice day. Thank you.